house. Okay, all right, so let's get started again. I'm Dr. Noor Shakir-Zweli. I'll be your lecturer for Group 3. Are you guys from the same program or different programs? Anyone from zoology?
Here.
Okay,
Me.
aquatic. Anyone from aquatic? One? Okay, maybe zoology only. Okay, anyway, I'm not from zoology. I'm from biotechnology program. Okay, I'm from biotech program, but I also teach statistics. Okay, so here is my background, some information about myself. My expertise is fermentation technology and industrial biotech. My contact details, you can see my email address. The phone number here is my office number, but I'm not at the office that really frequent at this time because I work from home, but you can contact me through email. Yeah, I'm quite alert with my email. Here is my Twitter, and then my education. I just got back from the UK 4 years ago. I did my PhD in biochemical engineering at University College London, and then my MSc at UPM, my first degree at UIA. I also got PGD in teaching and learning. And then apart from statistics, I also teach all the biotech courses, bioprocess tech, environmental biotech, scientific communication. Yeah, here's my interest. I love to travel. I love science communication. I founded biotechnologies at Unimas. If you want to know about biotech, we are on Instagram. And I'm also into digital product and content development. Okay, that's a little bit about myself. Okay, now let's move to the course. So this course is STF 1093. That's the code course. So every course has its code, and you have to know what it means, at least for this one actually. So if let's say anything that ends with 3, that it means that it is a 3-hour credit course, 3-hour credit. Yeah. So 1 here refers to the first year. Okay, and this one is statistics for biology 1. So you guys will have to take statistics for biology 2 in the next semester, I suppose. So yeah, there are 2 parts of statistics. Okay, so about the course, this course is about statistical methods, procedures for analyzing and interpreting quantitative parametric data. Okay, I don't want to go into all of these words, but basically, yeah, it's about statistics. Yeah, so I know that statistics, I'm sure that statistics is not a new word for you. You have studied statistics somehow before, yeah, during your STPM, during your matriculation, during your even SPM. Yeah, some of the things would be a little revision, but some of the things are extension. Okay, for example, there are few topics that we will introduce and you know already, but then there is an extension of it. Okay, so that's what we're gonna cover. Yeah, and statistics. You are in science now. You are in science field. You are in zoology or even maybe plants. Some of you, or aquatic science. But basically, you are in science field. But why we have to study the course? So it's because of we need you guys need statistics regardless of what kind of science field you are in. Okay, so that's why you have to take the course, and you will see the importance of the course throughout your time in your program or in your field. Yeah? So you need the statistics. Statistics basically is a tool. It's a tool for you to analyze your data, because when we talk about science, when we talk about research, we are talking about data a lot, and you have to use statistics to analyze your data. Okay, we're going to talk about it later, but basically that's what the course is all about and what the field is. Actually, statistics is a field. It's not just a course, it's a field. There are people who take statistics as their degree, yeah. So it's a field, yeah? But of course, you guys do not have to go into so in depth, but you have to know the basic principles or basic tools or basic things in statistics for you to apply in science. Because without statistics, you cannot go into interpretation of your science, okay? Right, so that's basically the importance of the course. So for this course, Stats 1, we're going to cover 4 learning units. LU stands for learning units. Not really into chapter. It's like, we call it like, yeah, we don't call chapter basically. The chapter is like more to books, right? Learning unit is like we just take few topics and make it as one learning unit, okay? But basically it's like division of the course. So we have 4 learning units. The first one is going to be Introduction to Statistics. LU2, Probability Distributions. LU3, One-Way Analysis of Variance, ANOVA. And the last one is LU4, Principles of Experimental Design. LU1 and LU4 is not that really long. LU1 we can cover in maybe 2 weeks. Yeah. LU3 and LU4 is going to be a bit long. It takes maybe 1 month, I can say, for LU2 and another 1 month for LU3. So under each LU we have subtopics. We have subtopics. Okay. And LU4 is not that really long. It's like maybe 1 or 2 weeks also. Okay. So so I would say LU2 and LU3, please pay attention to those LU because it has lots of topics and it's going to be a bit not to say challenging, but you have to take note that it's going to be a lengthier LU than LU1 and LU4. Okay, and for mid-semester exam, so it will cover until LU2 basically, yeah, like before, like semester. So we're going to apply the same. So we're going to stop at LU2 and then have the why is not sharing anymore? We're going to cover, hold on. We're going to cover LU1, LU2, and then we're going to have the mid-semester exam. Why is not on here? Okay, I was looking. Okay. Yeah, as I said just now, so after LU2, we're going to have mid-semester exam, which will be announced later. And then we're going to continue with LU3, LU4, and then final exam. Okay, right. So that's for you to know about the learning units. And then this is the lecture plan. So we're going to have LU1 in this first 2 weeks. Okay, and then LU2 in November, starting from November until towards the end of November. Then we're going to have the mid-semester exam. For the date of this exam, we will announce later. We haven't yet decided on it, but it's going to be maybe around after November, after we finish LU2. And then we continue with LU3 and LU4 at the end. Okay, so there is no mid-semester break. Normally we have a mid-semester break, like 1 week break after week 7. But this time around, it's going to be a bit packed. So it's going to be a continuous lecture throughout the next 3 months, 4 months, 3 months. Yeah. Okay. So get ready with that. Yeah. So yeah, just for you to be prepared. Okay, what else? Right, assessments. So what kind of assessments involved in this course? So it's divided into three. Assignments and tutorials carry 30% of the course, of the final grade, and then mid-semester exam carries 30%, and final exam carries 40%. So it's very important for you to take note on the assignment and tutorials. So it carries quite a lot of marks. You can actually try to score on that portion, yeah. And same goes to mid-semester exam. And assignment and all these tutorials and mid-semester exam, it carries, you see, 30 plus 30, 60%, right? So those are the marks that will be released before the final exam. So it's about per 60%. So you should try your best to work on that, because like mid-semester exam, it only covers LU1 and LU2. So, you know, like you got less burden compared to final exam. So take the opportunity to score on it, right? And also on the assignments and tutorials, okay? Right, okay, next one is, okay. So apart from ELIT, I'm sure that you know already about ELIT. ELIT is the official UNIMAS e-learning portal. It means that every course that you take, the information, the lecture notes, everything is on that portal, ELIT. And then apart from ELIT, I also use a few platforms to support our teaching and learning process. For example, I have created a Telegram group. The name is Statistics 1 with Dr. Ashikin. I'm sure that some of you have joined it. I could see quite a lot of you have joined it. So this one I will use just for quick announcement, and also for sometimes if let's say I don't conduct any live lecture, I will conduct a session on it. Okay, so please join it. Yeah, but some of the information I would also post on ELIT. For example, announcement, the information of the class, I will also put on ELIT, but you can refer to the group as well, yeah, for a quick announcement. And then I also have this YouTube channel named as No Statistics, No Talk. So please join it. Normally I post recorded lecture on this YouTube channel, but I also later embed the video in ELIT. But it's just for you to know that I also have this channel. Okay. All right. I think that's it about the information. Any questions so far?
No, doctor.
Thank you. I think it's quite okay, I hope. Okay, so now let's move to the first lecture. Okay, so since you guys do not have any questions on the course, yeah, let's move to the first LU, first learning unit. I will call LU, but you have to know it stands for learning unit. Okay. So in the first LU, we're going to talk about introduction to statistics. So it's just a revision, it's just a recap of what statistics is for you so far. Yeah, you have come across statistics before. So in this, we have this part one. This is actually part one. So we're going to see what is statistics, why we study statistics, some definitions, statistical definitions and concepts, terminologies that you need to know when you are in this field or in this course. And then what types of data, because we are going to deal with data a lot. So you have to know what types of data. There are two types, quantitative and qualitative. And then there are two components of statistical analysis. Descriptive versus inference statistics. And then statistical tests, they are parametric and non-parametric tests. Okay, so let's have a look at first, what is statistics? What is statistics? Right. So statistics basically is a study about how to collect, organize, analyze, and interpret numerical information from data. So you can see those terms: first collect, organize, analyze, and interpret. So each of that represents different stages of data analysis in general. Okay, so collection means like when you want to get the data, you have to collect the data. So normally we call it collection, data collection. And the way how you collect the data, there is a principle, there is a method of it, okay? And it is covered in statistics, in the field of statistics. Okay, so this is collect. And then once you collect the data, we call it like, let's say you have data, so many data, right? And this is what we call data. And what do we have to do with that? Before we go into interpretation, interpretation is the last one. So the second step is organize. Organize. So all the data, let's say you have the data, it is in, it is not in ordered form. It is in random form. So you have to organize. And how you want to organize? In statistics, we learn how to organize it. We learn how to make it in an organized form, okay? So there is another step after collection, organization of data. And then after organization, no, we're not into interpretation yet. We have to analyze the data. We have to analyze the data. And what kind of analysis that we're going to do? There are so many analyses in statistics that you have to know. It depends on the data type as well, okay? And just now when we talk about data, there are two types of data, quanti, and quali, we call it. So analysis of the data depends on the types of data. So analysis of quantitative data is not the same as analysis of qualitative data. So that's why there are so many things that you have to know, the basics of the data before you go into the analysis. Right, and the last one is interpretation of the data. So once you have analyzed, once you have organized, so you have to interpret. So what is meant by interpretation? So it means that you have to make a conclusion about the data, what the data means, because that is actually, why is my screen today? So many problems. Because this will bring to the conclusions. Because this is actually the ultimate aim of statistical analysis. We want to get what the data is all about. So what? Okay. So that's the ultimate stage, ultimate aim. Yeah. So all of these stages, yeah, so is covered in statistics. It's not covered in science, in zoology, in whatever the science field it is, but it is covered in statistics. So that's why you have to study statistics. Even biotechnologists also have to study statistics. Chemists, plant botanists, whoever, okay? Even social scientists, those who are in social science, not in science. In any field, we have to study statistics. So statistics is a universal field or tools that need to be covered by everyone, okay? Because we need it as a tool. All right. Enable us to look at information, make inferences. Inferences, yeah, is a tool to analyze, interpret data. Okay, I'll talk about it. Okay, general precondition is the gathering of data. Okay, so I just want to emphasize on important notes, terms, variable. So in statistics, we're gonna refer, we're gonna mention about variable. Variable is what is variable? Is the characteristic of the individual or object to be measured or observed. Okay, for example, you want to analyze the height, distribution of height among students at UNIMAS, okay? So let's say the object, or I mean the things that you want to measure, the sample are the students. These are the students at UNIMAS. So what kind of things that you want to measure? Just now I mentioned about height. So let's say height. It can be anything, like maybe background, apa ni, hometowns, maybe contoh. Hometowns or gender, right? So this thing is the variable. It's called variable. Okay? So it's the thing that we measure, the thing that we want to get information from the subject, from the object to be measured. Object to be measured here is the student. Okay? So variable. So in statistics, we're gonna refer variable a lot. So if the next time I say about variable, you should know what it means. Okay? Right. What else? Statistics give us tools for meaningful patterns in the data we collect while taking variability into account. It also provides the theory necessary to determine whether we can conclude what the patterns we see would hold in a more general setting. Okay, now let's say just now I mentioned a very simple example. I want to measure, I want to know about the distribution of height of the students at UNIMAS, right? So at first, of course, I would collect the information about the height. Okay, what is the height of student A, student B, student C, and so on, until depends on how many students that I want to observe, right? So that is the raw data. Let's say I have the data. Okay, just now we talked about that data collection, right? Data collection. Okay, let's say I have my sample is about 50 students. So I have the height of 50 students. Yeah, so 50 students. So these are all data, right? So this is what I call raw data. I just collect it and I don't organize it yet. So I have student A, student 1 until student 50, the information about their height. So this is data collection, okay? And then what I'm going to do next is organization. Remember the step just now? I need to organize the data. So in order for me to find a conclusion about the height at the end, I have to go through all the stages: collection, organization. How am I going to organize the data? So let's say the minimum value that I got about the height is maybe 150 cm, for example. And then the maximum value that I got is about 175 cm. Okay, so and the rest are the values between these two values. So what I have to do with that, I have to organize. I have to know, like maybe 100, starting from 150, how many people got has that height, and then 151, 152 until 175. So that is all about organization. Okay, organization. Maybe I create like a table. Let's say this is the height and this is the frequency, and starting from 150 until 175, how many people got that height, yeah, that particular height. So that is about organization. And then the third stage is analysis. So this one is 1, 2, and the third one is analysis. So what I meant by analysis is I need to know, like, what is, for example, the basic. I just give you a very simple example of statistical analysis. It's not just this. After this, we're going to have lots of types of analysis depending on the data. So what kind of analysis? Simple analysis, mean. Do you know what is mean or average? I'm sure you know that, right? So what is range? Range, of course, like I mentioned, 150 to 175 cm, because that's what I found from my data. And then we also have variance or standard deviation, things like that, okay? But the easiest one for you could understand is like average. It means that how in average, what is the normal height of students, of these 50 students? So I have to find the average, right? Divided by the 50 students, okay? So this information, just now, let's say this is raw data, or we call it primary data. Raw and primary is the same. Primary means it's like the first hand of data. So this one, let's say information, let's say I got average when I count the average, I got like 160 is the average, 160 cm. And this is the range, and standard deviation maybe plus minus 5 cm. So this information is secondary data. Why it is called secondary? Because they are derived from the primary data. Like means that based on the primary or raw data, I do some analysis. This is what we call analysis. Like when we calculate the mean, when we calculate certain parameters, it's not only this. So those things will create or will form secondary data. So during the analysis, we will get lots of secondary data. So based on the secondary data, we got ideas. Okay, we know that the average is this, we know this and this. Because from the primary data, we cannot know anything yet. We cannot know, I mean, we cannot see the trend, the pattern, and so on. So based on the secondary data, once we have this, we can create like maybe a graph or maybe a pie, a chart pie. And then maybe we can create whatever the presentation, what kind of data representation. And let's say I want to create a chart pie, sorry, a pie chart, and then maybe if I want to make it like, what's this, 150, 100, yeah. So it's distribution of height, okay? Let's say this one is 150 to 155 cm. And this is 155 to 160 cm. Like how many percentage of people who got this? Let's say this is, let's say 25%, this is 15%, something like that. So based on the secondary data and based on also the data organization, I could create something that can tell people in an easier way, right? When you see this kind of chart pie, or when you have a look at the, maybe it's not only one type of representation, it could be graph, yeah, it could be maybe bar chart, and you have to know like different types of data representation, okay? And how to choose which kind of graph that you want to present. You can see, you can determine by yourself the suitability. Let's say this one, maybe chart pie is suitable, or maybe bar chart is also suitable, right? Because it will give a picture about the data easier, okay? So based on the secondary data, based on the data organization, we can present the data in this kind of charts or graphs. And at the end, when we go into the last stage, which is interpretation. Okay, based on this one, now we can interpret the data. Okay, interpret. What interpretation is? We make a conclusion. Okay, majority of the students have the height of what? Maybe, yeah, 50% have the height of between 150 to 160, something like that. Okay, so it's about conclusion. It's about it's about the description about the data. So that is actually what we want, isn't it? Like when we want to carry out survey about the height, we want to know at the end how many, what is the percentage of students in this range of height, right? So without all of these steps, we cannot reach interpretation stage without the data collection, without organization, without the analysis. So it's very important to go through all these stages in statistics, because we want to reach the conclusion of the data. So the same thing goes for any examples in science. This is just a very, very simple example. For example, in zoology, when you collect various types of data, maybe you will be dealing with studies on insects, studies on what else? Birds, animals, whatever animals. I'm not an expert in zoology, so just yeah, just throw out ideas. Let's say you want to measure maybe distribution of the size of the insects or things like that. So you have to collect data, you have to analyze the data, and your data will be, you know, this kind of things. It could be quantitative, it could be qualitative. So this example just now is quantitative data because it deals with number. Quantitative. Quantitative means something related to number. Okay. When it is something related to features, characteristics, that is qualitative. For example, if let's say you are analyzing the distribution of okay, I'll give you a simple example. Distribution of hair color, very simple. Hair color of students' hair. That one is, it could be black, brown, white, yellow, right? It's colors, it's something that it's not dealing with number. That is qualitative, features, yeah, characteristics. And in science, for example, in when let's say you are analyzing the morphology, something related to morphology. Morphology means the physical characteristics. Let's say we are bacteria. When let's say you are analyzing bacteria under the microscope, you would see different patterns of bacteria. Some of them are in rod shape, some are in spear, some in in filamentous form. So that kind of words, terminologies to describe them, that describes the quality. So that kind of data is called qualitative data. Okay. All right. Yeah, I think I've gone through all these steps just now. This is just a different example. Okay. Collect, organization, analysis, interpret. So just keep that. Okay, why we study statistics? As I said just now, statistics is not only in science. We need statistics in different fields, like in weather forecasts, in share market, in finance, in sports, games. Why? Because we need to know about sometimes prediction. What is the maybe probability of winning the game, something like that. In advertisement, yeah? So we deal with a lot of data, numerical data. In business, it's about profit, things like that. It's about percentage of revenues, whatever. Yeah? So it's not only in science, but of course, we are going to focus more in science because we're scientists. So yeah, talk about it. Okay, why we study statistics? Because at the end, you want to make a conclusion about your science. Without statistics, you cannot analyze your science. You cannot analyze your scientific data. You cannot conclude about your science. Okay, so that's why statistics is a very important tool that can't be neglected by scientists, and especially in research. Yeah? It's like I can say how I can conclude. Yeah? Let's say now we are doing science, whatever science it is, like maybe chemistry, zoology, plant, or aquatic science. You are investigating about the nature of whatever, like the animals, the plants, the aquatic organisms, microorganisms. You're doing science. I mean, like you're collecting the information, like just now, let's say you are analyzing the characteristics, morphology of bacteria under the microscope. That is in your field. But before you go into the interpretation at the end, you have to go through the statistical analysis. So the statistics always comes after the science. So let's say other examples like collection of quantitative data, like you want to analyze the distribution of height or maybe the length or dimension of insects from certain areas, right? So you're going to collect insects and then you analyze maybe the height of whatever the organs, I don't know the terms, the fragments of the insects, right? Maybe the leg, the head. So you have that data. But then how are you going to make a conclusion? You have to go through the statistics before you go into conclusion. So as I said, is very important. You cannot neglect it in whatever science field you're in. Okay. So when you study statistics, yeah, just now when you know about average, mean, average. So you know about standard deviation. You know what standard deviation is? When I say, let's say standard deviation, just now the height, okay, the mean just now, let's say the mean of height, let's say 160 cm. And then standard deviation is 5 cm. What does it mean? 5 cm. Okay. So
plus
normally,
minus 5 cm.
yes. So when we normally present the data, we normally present the mean value, whatever the mean value, and then sometimes you might notice that it is accompanied with plus minus 5 cm, as your friend said just now. 5 cm, plus minus here. No, not necessarily 5 cm. This is just an example, but the plus minus value after that represents standard deviation, meaning to say that the deviation, meaning to say that macam mana, how much the values, just now we know that average is average lah. I mean like the mean, the middle value lah, 150, and then let's say 170 lah, the range. And then the mean is 160 cm. Means that the middle value, average value yang orang dapat in between this range. So what is the standard deviation? Means that how much from the mean it deviates. How much it varies
like
from
estimation?
The mean. Say again?
Is it like estimation?
It's not estimation, but it's something that based on calculation, that how much normally the values from the mean it deviates, you know. So that's why it's called standard deviation. I think we would cover that after this, after maybe in some there is a subtopic on standard deviation, but it is to say that the deviation from the mean value, yeah, deviation from the mean value. That's what I can say at the moment for you to understand. So means that how much deviation from the mean value it is 160. So it could be like, if let's say we talk about 160 minus 5 cm is 155. Normally it's actually like the average or the deviation is actually between 150. Salah. Sepatutnya kat sini, let's say 155, and then this one is, let's say, plus 5, 165. Let's say I put it the range, new range. So let's say plus minus 5. In this case, 160. 160 minus 5 is 155, and 160 plus 5 is 165. So it's like, you know, it covers the range, but then the mean value and the standard deviation, it represents like the middle value and the deviation. Yeah, I hope you understand what I mean.
Does it mean that we're looking for a certain range? Therefore, the standard deviation is basically something that, like, the data will be accepted if it is plus minus the standard deviation. Therefore, like a range.
Yes. It's actually like yeah, the mean value, you know, the mean value, and then the standard deviation is like how much it deviates from the actual range. That's why it's like plus minus. Plus minus 5. Let's say minus 5 is 155 and plus is 165. It's between that range. Okay, we go into that in some of the subtopics about standard deviation for you to understand. But it's one of the parameters that we take note in statistics apart from the mean or average values. Okay, so when we know about these parameters, the mean, standard deviation, variance, there are so many after this. So it means that we have basics in statistics, and when we come across any information from, let's say, from the news, from the whatever the, whatever the sources, like the papers, the books, we know what it means. If let's say we do not know about average, for example, what is average? When people say the average height of students is this and this, if let's say we don't know about statistics, we don't know what it means, right? So when we have a good knowledge in statistics, we know how to interpret the data. So that's why we, it is very important for us to study statistics, for us to evaluate, for us to interpret the data, right? And also, yeah, these are all the things. Learn the rules, evaluate and assess the importance of published statistical findings, and then learn the aspects of statistical thinking, and to better understand the empirical world around us, and particularly in science. So for us to understand the science better, actually. So that's the importance of statistics. Okay, now moving to statistical definitions and concepts. Okay, so there are several terminologies or concepts that you have to well verse when we are in statistics, because in order for you to understand how the analysis will go. Okay, so the first term is population. Just go first. Sample. Data, when we talk about data, is like pieces of information. Yeah, parameter, statistics, parameter, characteristic. We also have this parameter. Also, sometimes we say variable. Variables, parameter is quite the same. Just now we talked about variable, right? Variable, or things that things that we want to measure, some things like on the things that we are interested in. Okay, population. Population is something related to a large group of audience or objects or people. Okay, let's say when we talk about population in Sarawak, population in Malaysia, population in Unimas. Okay, so it means that it covers everything within that subject. Okay, and when we talk about sample, let's say this is population. Let's say we talk about population of students in Unimas. So we can define whatever the population that we want to talk about, but as long as it meets the requirement of what it is, it has to be population. Like, for example, population of students or population of Unimas. So we know that Unimas is an organization. It has many, let's say, faculties inside, right? Let's say faculties. So it can be a population. Unimas can be a population. Okay, Sarawak can be a population because it has subsets. It has districts. Malaysia can be a population as well because Malaysia has different states. States is the subset of it. Okay, so let's say Unimas population, and we have many faculties. So now the faculty is the sample. Okay, inside the population we have a small portion, subset we call it. Subset. So that is sample. Okay, subset is the smaller portion of a population. Okay, sample. Now we have population. This is population, and this is sample. Okay, and inside the population there are many samples. It should be more than one sample. Then only then it can be called a population. Okay, data. Okay, when we talk about data just now, I've mentioned about data already. So data are the things that deals with information about whatever, about the population, information about the population, information about the sample, right? So it could be, it could be information about the sample, it could be information about the population. So when we have the information of many samples inside the population, we call it population data lah. Yeah? So basically it's a pieces of information that describe something, describe height, describe gender, describe hometown, describe characteristics of features of students, whatever. And then parameter or variable, a number describing some characteristics of the population. Okay. Normally parameter variable, sometimes we, I would say it's about the same. When I say parameter, it's like maybe, yeah, it's variable. It's like just now when I say height, weight, or maybe hometown, gender, maybe what else? Habits, or like apa ni? Internet browsing frequency, something like that. Whatever the information or things that describe the population or sample is called parameter or variable. Okay. And then when we talk about statistic, okay, so you normally when you say that when we read like news, right, articles, the statistics show that this and this. The statistics show that the number of people who receive vaccines is maybe 80% already. So the word statistic is used. It shows that the summary of the things. In, let's say, yeah, I know that statistic is the name of the field, but when we are outside the field, let's say we have already the data, like when people report it in the news, the statistics show that this and this. So people will refer that the whole thing about the data or analysis is statistics, okay? So here you can see that it is a descriptive index or numerical summary which can be computed from a sample. So this is just about the term. Yeah, we use statistics to make inference about population parameters. Okay, so what does it mean here? So why in population, we have to know that there are many samples, and what actually these samples represent the collective information of all the samples. Let's say we talk about UNIMAS population just now, right? Like maybe how many students in every faculty that have received vaccine, for example. Let's say we have faculty of, our faculty is Faculty of Resource Science and Technology, or FRST, or FSTS in Malay. And then we have Faculty of Engineering, Fakulti Kejuruteraan, Faculty of Economy and Business, apa lagi ya? Faculty of Science, Social Science, FSS, Applied Creative, PAKA. Let's say this represents like the number of students who have received vaccines. So what is the importance of the data from the samples? It will represent the data of the whole population at the end, isn't it? Does it make sense? For example, like, you know, you got data from each of these faculty. At the end, you can conclude, summarize the population, which is in this case is UNIMAS, the number or the percentage of people who have received vaccines in UNIMAS is 90%, for example. Because how you got it? You got it from all the samples. And that's why you have, it's very important for you to identify the right samples. You cannot just say that you just collect from 2 faculties, FRST and FK, and then you want to conclude about UNIMAS at the end. It's not fair, isn't it? It's biased because it doesn't cover all the university. So it should, in the first place, it should cover the whole faculty, and also the number of samples that the number of samples should be reliable. It's not just about like, even though if let's say you have all the samples, like you have all the faculties, but each of the faculty you just analyze maybe 10 students. So it's not enough lah to actually to conclude at the end. So those are other things that you have to take note when you are analyzing statistical data. First is like in terms of the relevance of the samples. It should be conclusive. Yeah, it should cover all faculties, like for example here, and it should cover a lot of people, maybe more than in statistics. more than 30 is considered, not more, it depends on cases juga lah. More than, it's a lot lah. Maybe like the more data is more reliable. Okay. Let's say you have 100 students, is more reliable than 50 students, the number of students. So yeah, those kind of things are very important in order to make inference about the population. Okay, I hope that makes sense. Right. So that's the importance, the relationship between sample and population. Why we need samples to conclude the population. Okay, I've covered this as well. Types of data. Yeah, I've mentioned about it just now. So in statistics, the data can be divided into two types. The first one is quantitative. You can see the difference is N. This one, another type is qualitative. Quantity, something related to numbers, numerical values. Okay, so this one is something to do with numbers, measurement, and there are so many types. These are examples of it: the weight, the length, area, whatever related to numbers. Okay. So that is quantitative. And the second type is qualitative. So qualitative means something related to the qualities, attributes, features, characteristics. Yeah? For example, gender, males and females. Political party affiliation, maybe party 1, party 2, right? So, you know, it's very unique. I mean, it's not something that you can measure. There's no number. Yeah? Like this one, size, S, M, L, XL. Yeah? Color, we talk about color of, colors. Red, blue, yellow is something very unique. Yeah? So that is qualitative or characteristics. Okay, so those kind of data is qualitative data. Okay. The reason why we have to identify this kind of data, because it will determine the analysis, determine the methods or the statistical methods. Because in statistics, we have lots of methods, and some of the methods are designed for quantitative and some are for qualitative. Okay, so now, when we talk about quantitative data, it is further divided into two types of data, whereas which are discrete and continuous data. So what does it mean by discrete and continuous data? Discrete means, like, let's say how many students are in FRST. So there are maybe 1,000 students. Let's say I put it like a number. Let's say number of students 1,300. Okay. So this kind of number is a type of discrete data. So why I say it's discrete? We don't have 1,300.75 students. Does it make sense? But again, so it's like it's just about how to say that? It's just one solid number lah. Let's say 2 students, 3 students. I don't say 2.5 students. I don't say 2.79 students. Yeah. So this kind of data is discrete. We call it discrete. So what kind of things that involve discrete data is like, this is the term. I was looking for this term actually. Whole number. This is what we call whole number. Okay, there is no decimal points. But in some situations, we need continuous data. For example, the easiest one just now is height. When I talk about height, there are some who has a height of 150.1 cm, or even 150 point, even 1, we can say 1.5, 1.6, 1, you know, like it's continuous. There's no limit for it. 150.2, 0.3. So they are basically, they are decimal points. So this kind of data, we call it continuous data, okay? Because it's not gonna be, you know, any limit of it. Like, for example, the weight, the height, the time, 1 hour, 30 minutes, 5 seconds, you know, like it can be like in tiny fractions of it that we cannot measure. So it's continuous. Distance, like for example, 25.761 kilometer. Even you can go for, you know, like much more specific, but it's going to be like continuous. Pressure, temperature, 37.571 degrees Celsius, for example. Yeah? Age, you can say 2.5, yeah, when we talk about age, like maybe 3 years, 10 months, 1 day, something like, you know, like that, continuous. But when we talk about number of people, number of children, number of cars, number of cats, salary, okay, salary could be continuous also. Heart rate. Speed of a car. I think this one is continuous. This is wrong. Okay, so we're talking about number lah, numbers now, number of things, number of items. It should be whole numbers. You cannot say 1.5 cats, 2.5 cars. Yeah? So this kind of information or data is discrete data. Whole numbers are discrete data. Continuous data are those that involve decimal points to make it easier. Okay, this is just an example. You can go through by yourself. It's not that really hard. Apa ni? I just skip some of the things just to make our lecture shorter. Yeah. Okay, I think this one you can go through by yourself. It's not that really difficult. Okay, 2 components of statistical analysis. So these are another things that you need to take note. Yeah, so you can see that there are so many terminologies that you have to go through and understand, right? So just now we talked about quantitative, qualitative. Okay, now it's about descriptive and inferential statistics. So what are these two things? When we talk about statistical analysis, they are branches of statistical analysis. Okay, the first one is descriptive analysis, descriptive statistics. So what does it mean? It means that we describe the things from the data that we have. Like for example, just now when we talk about height, okay, the height is this, the mean is this, you know, it's about the present thing. So we describe it, we describe the data. So that's why it's called descriptive statistics, okay? So examples of it are these lah, the parameters, the mode, the mean, median, standard deviation, variation, and how we present the data in terms of graphs. We could use all these means, yeah? Plots, bar charts, pie chart, histogram, graphs, stamps. So there are so many ways how to present. Now, moving to inferential statistics. Inferential statistics is something to do with we have the information or the data, but we use that information to estimate, to predict, to make forecasts. Yeah, so this kind of statistics is very important for example, weather forecasts, or maybe in business, when you want to estimate your profit. Let's say you have this and then you want to estimate your profit, how much revenues that you'll get. So it's about estimation or forecasting, okay? So that is the importance of this kind of statistics. We call it inferential statistics. And it's all about making estimation, making prediction, yeah? Let's say how much is the probability of winning the game, for example, based on the previous records. Let's say, for example, team A has won maybe 6 out of 10 games with team B. So maybe the probability is about 60%, something like that. It's about making prediction. weather forecast for apa lagi ya? Prediction of revenues. Let's say based on the data that we have for the past months, how many revenues that we will get next month, profit that we'll get next month, based on the trend or the current trend or the past trend, or maybe there is an increase of profit, something like that. Okay, estimation is about estimating the future events. Okay, so that kind of statistical analysis is called inferential statistics, and it's important because it is used in, as I said, the field like business, games, or sports, or weather forecast, or in share market. Yeah, you want to know about the shares. Yeah, so that's the two types of statistics. So normally in science, we deal a lot with descriptive statistics because we want to describe our data, our scientific data. But also sometimes there are also some components or some fields that require inferential statistics because we want to predict, like maybe that one is more to simulation or modeling field. I think in zoology also there is that part, but maybe you will deal a lot with descriptive statistics because it's based on what you have in the lab, okay, or what you have in your maybe in your practicals. Yeah, this is some of situations. Yeah? For example, let's say the first example there, a bowler wants to find his bowling average for the past 12 games. So that is an example of descriptive statistics because you just want to know about what it is, yeah, the description of what the current things. Okay, the second one, a bowler wants to estimate his chance of winning an upcoming tournament based on his current season average and the averages of the competing scores. So you can see that this is like about estimation or prediction. So that kind of thing is inferential statistics. Okay. Yeah. In politics, a politician wants to know the exact percentage of votes cast for her in the last election. Yeah. So, for example, in election, also right, we also based on the previous data of votes. Okay, what is the percentage of winning for the next election, for example? So in politics also we need statistics. Yeah? We need this kind of inferential statistics. Okay, something related to the science. A botanist wants to predict the rice yield for the coming year on the basis of growing trends over previous years. In science also we need inferential statistics because we want to know like the trend of the growth of maybe plants or bacteria. Yeah. Yeah. What else? Descriptive is very straightforward. Yeah? Describe the variation in a 5 tutorial study course. So you can see here for the inferential predict in the future test marks. Okay, so I think that's quite understandable. And the last one is a parametric and non-parametric test. So the tests in statistics can be divided into two broad categories. The first one is parametric and non-parametric tests. So in statistic 1, we will cover parametric tests. Statistics 1, I mean the course. Statistics for biology 1. Biology 1, yes. So you're going to have to take another course, statistics for biology 2. So in that course, we're going to cover non-parametric tests. Okay, so in this course, we're going to deal with parametric tests a lot. So, but what's the difference between these two tests? So when we deal with data, so the data, it can be sometimes in certain occasions, the data is, the size of the data is big, okay? And sometimes in certain occasions, we don't have choice. The data of the size of the data is small and we don't have options to increase it, that kind of thing. And for example, in the case of the size of data is big, right? So because of this is based on what the statistician have done the research. So when they say that when they deal with a big number of data, sometimes the data will follow certain trends. The easiest one is a normal distribution. Have you heard about normal distribution before? Normal
Yes,
distribution?
madam.
Yeah,
Yes.
okay. All right. So when we talk about normal distribution, it's something to do with bell curve shape, we call it, right? So the easiest way, the easiest example is like, for example, if I say, okay, just now height. So normally we have certain average height. I mean, not so many people are too short and not so many people are too tall, right? So let's say for Asian women, it's from 150 to, or maybe 148 to 170 Asian women. Let's say 148 cm to maybe 175. Let's say lah the maximum. Okay. So if let's say we do a survey, we collect the data from a sample. So we would find, regardless, let's say sample, let's say this is what statisticians have like concluded. The data will at the end follow this curve shape or normal distribution. That is the assumption that they make, and is normally true. Is normally true in many cases. Provided that the data size is big, like maybe 100 people, 200, 1,000, it will follow the bell curve, the normal distribution. Yeah. So this is based on the basic or typical assumption made in statistics. So let's say, for example, just now I want to collect this height, and my size, data size is 100 or 1,000 people. And at the end, when I plot the graph, when I analyze the graph, I would see that the pattern will follow somehow this normal distribution. And it is normally true, because I think this is something to do with the law of nature. The average will sit in the middle. Like average, let's say for Asian, maybe 155 to 160, for example. Yeah? So normally, most of the women will have this height, Asian women, and very small portion will have this height, and very small portion will have this height. And yeah, this is something very common. Yeah. So based on that, the statistician, they have come up with this kind of rule of thumb that normally the data for big size of sample, it will follow normal distribution. And this one is just an example, height. If I talk about maybe even let's say when we analyze the marks at the end for lecturers, when we, after the final exam, we have to analyze your marks, like we have to analyze for every course, what is the performance. And the performance is always, it always satisfy this normal shape, and which really makes me amazed lah. I feel that people who have concluded the normal distribution, they are very correct. When we analyze, not many people will fail, like for any course, maybe small portion, maybe 2 or 3% will fall below 40 marks, for example, and not so many will get like 95 and above. Like 95 is considered like excellent, very excellent marks, right? 95 to 100. Maybe they are, but only 1 or 2 students. And the average will sit in the middle, who get between maybe A minus to maybe B, like that. Okay, maybe like between 65 or maybe to 75. The average portion will, like big population, let's say maybe 40% will get around that marks. And when we graph the distribution of the marks, it will follow the normal distribution. That is just an example. So to say that in many cases, in many events, when it deals with a big number of data, it will follow this normal distribution. And that is the normal assumption met in many cases, dealing with a big size of data. So that's why this one is spelled out in statistics. You have to know about it. So this is assumption, normal assumption when we make about the data. But what happens if, let's say, we have a small number of data. Let's say in certain occasions we don't have choice. We have to just analyze maybe 10 points or 10 data. Okay, and looking at what the statisticians have concluded, sometimes it's very hard for small number of data to satisfy the normal distribution. So in that situation, more often than not, we just do not make any assumption. We do not know actually how these 10 data behave. So in that situation, that falls under the category of non-parametric data. This type of data is non-parametric data. And in that situation, we have to use non-parametric tests to analyze the data. Okay, so when we talk about the types of data just now, it is associated with a test. Parametric data, we need parametric tests. Non-parametric data, we need non-parametric tests. Okay, that's just one example. And also for a non-parametric data, that it is also used for is used for data that we don't make assumption about it because of, for example, just now, because of the data is too small and maybe we don't have much ideas about it. Okay, that falls under non-parametric type of data. So enough for me to say at this time, because I'm sure that you're a bit maybe you're not clear about parametric and non-parametric. Parametric data normally deals with data that is large in number. In statistics, we define it more than certain number. And it follows normal distribution. Okay, and for non-parametric data, normally it deals with a type of data that may be small in size and it doesn't follow any assumption. It doesn't follow normal distribution like parametric data. Okay, I hope that's enough at this point for you to understand the types of the data and the tests. Okay, so yeah, we're going to deal with parametric tests or parametric data a lot in this statistics 1 course. I think that's it for the intro. We're not done yet for this session. Any questions so far? What we have discussed for the past 1 hour, we have studied what we know, what is statistics in general, why we study statistics, some definition and concepts, the types of data you should know now, what are quantitative, what are qualitative data, the 2 components of statistical analysis, descriptive and inferential statistics, and the types of statistical tests, parametric and non-parametric tests for data. Okay,
Doctor, I have a question.
Yes.
So because especially the 2 components of statistical analysis. So in my point of view, because I want to make it easier for me to understand. So in descriptive statistics, basically we can basically in in descriptive statistic, would you say that it's something that could be determined through the data, while in inferential statistic we can only merely not reject something, like, because in my previously I learned basically how, like, they're in hypothesis testing especially, you cannot, like, you can only reject and not reject a certain assumption, right? So in some sort of way, would you say that the description statistic is something that is already for sure, while the inferential statistics is something that we can only not reject or reject? Do you know what I mean?
Yes. Yeah, I got your point. So yeah,
Okay.
correct. Descriptive statistic is something that we determine and we describe as it is. Like, we have no doubt about it. Like when we say that the mean is this, I mean, there's nothing to disagree about it because it's there, you know. But when we talk about inferential statistics, you're right. There is a possibility to accept this and to accept that. It's just about estimation at the end. But that estimation is still important because at least we know, we have an idea about like probability of, let's say, winning. We can say that at the end, maybe it doesn't meet that probability, but at least at that point of whatever the thing is reported, we have some ideas about the probability, about the estimation, about the forecast. You know what I mean? Yeah, you're right. You're right. In inferential statistics, we just can say that these are the possibilities, but we cannot say that we have to accept this and reject this. We cannot say that we have to accept that the probability is 60% and that is going to be true. That doesn't make sense because it depends on what happened after the event, isn't it? So it's just for the sake of inferential statistics, it's just for the sake of getting an early idea about the event, about whatever is coming up, you know? Yeah. Did I answer your question or your doubts?
Yes, understand. Thank you, doctor.
Okay, thank you for your question. It's a very good question and things to discuss. Okay, anything else? Anything else? You're clear about population sample? There's a very, very important concept in statistics. Can we have a 10-minute break? I think it's good for us to have a break before we proceed with the second part. 10 minutes?
Okay, doctor.
Yeah, sure. So we'll meet again around 12:40. Yeah? 12:40 dah. Oh yeah, 12:40, yes. Okay, you can have a break, 10-minute break. Okay, we resume our lecture. Okay. So I hope everyone is back already. Yeah. So we are in part 2, LU1 still. Okay, so this part is a bit a little deeper. Okay, just now it's just an intro. So I hope that you take note on this part. Okay, so the learning outline for this second part, we're going to have a look at this subtopics, summation notation, and then we're going to have a look at how we're going to present the data. This is about more to, I can say, data representation. Okay, data presentation. Okay, some of it may be just a revision for you. Maybe you have covered it during your SPM, STP, and matriculation. And maybe there are some more extension from it. Okay, like first one, summation notation. Okay, this is just about introduction of this thing actually, because we are in statistics, we're going to do lots of summation, and we have to know the right symbol, the right term. When we talk about summation, means that we want to total up things. And when we deal with lots of data, it's not just about a single type of data. We're going sometimes to have a cross product and so on. But the first thing that you have to know about summation is this symbol. Sigma is a capital sigma. So by right, you should understand if this term is used, it means summation of whatever the things within that, the data within that subject. Okay, right. For example, here, if let's say the summation of xi, I normally refers to the thing inside that subject, whatever the it means. So it means that whatever it covers from the beginning until the end. Xi is referring to the general term for the subject in it, the things in the subject. Okay. Okay, let's have a look at some examples just to make it much clearer. So the summation, let's say this one is, yeah. So it could be from, let's say from 1 to n, from 1 to n. And the type of summation, it could be various. It could be just not just, let's say x is just a single thing. Like for example, you just add up whatever it is, 7 plus 6 plus 5. But sometimes it could be like summation of xi square, xi 2xi maybe. Something that there's so many things that it will involve. Okay, so you have to take note on the brackets sometimes. For example, like this one, the summation of x, and at the end you square it, it will not be equal to this one. Okay, so you have to be very careful with the brackets apart from the symbol, the summation symbol. So yeah, for example, this one is a cross product. This is just a revision for you. I don't have to go into so detail, yeah, just to revise with you what you have understood before. Okay, so for example, summation of xy. So it will involve, let's say you have the data of x and y. So it means that first you have to multiply the things. xy, 3, for example here, 3 times 8, 2 times 3. And then this one is actually the one that you have to sum up, right? This one is referring to this. And this is the value at the end that you will get. Okay, so this is what we call cross products, x, y. And yeah, it could be various. Yeah, it could be sometimes you multiply the total summation with a constant. For example, like this one, a could be a number, a constant number. Okay. Yeah, this is an exercise if you want to try. Okay, you want to revise your understanding about summation, you can do this later at home. All right, so that's all about summation. Lastly, you have to know the summation and you have to take note on what the summation is all about. Yeah, the subject is all about. It could be cross product, it could be single product. The second part is data presentation. There are few points or few subtopics here, but basically all of these concern with data presentation. So what it means by data presentation, when you have the data, how to present it to people, how you want to tell about the data. So you have to present it in a way that can be understood by the people. You cannot present the raw data, right? Like the one that I showed just now, the raw data, like the data that you have collected from the first point to the last point is going to be like very confusing for people to know. Right? So you have to present it in a way that can be understood better, can be interpreted easier and faster. Yeah. So whenever you see the, let's say the pie chart, like distribution, how many percentage is this and this? So you got an idea instantly, right? Without you having to go through the raw data from one point to another point, then you don't know what it means. So that's the importance of data presentation. And in order to know what type of method, what type of graph that we want to choose, we have to understand what are the available options in statistics. And from there, we can relate with our data, which one is suitable, okay? Maybe sometimes we need just a table. Maybe we just need histogram. We need OGIF. We need maybe just a simple bar chart, things like that, okay? So it depends on our data and also the suitability of those methods, okay? First, let's have a look at frequency distribution, histograms, OGIF, and stem and leaf. Okay, frequency distribution. Okay, I talked about raw data just now. It's the data that you got directly from your data collection process, right? So the second step is you organize the data. When you organize the data, you also group your data. Grouping data means that you group it according to certain aspects, certain criteria, right? And when you group the data, so this is we have this kind of we categorize or group the data based on categories or classes. Maybe you divide it into few subclasses. This range, how many data are there, right? So we have categories, classes. And then based on the data just now, let's say you have raw data, you also have to know frequency. What is meant by frequency is how many times the data occurs. Let's say, how many times? Frequency, it could be, it should be a number at the end. Let's say 5 times, you put the frequency is 5. And then, it's up to how many times it occurs. So, but it is called frequency of the measurement of the occurrence, yeah? And it is denoted as F in statistics. So those things you have to take note when you organize your data. And then when we say frequency distribution, now we know already what is frequency and what is meant by distribution. Distribution means like the overview about the whole data. Distribution, we call it distribution in statistics. Let's say we have just now when we collect the height of students, we have raw data, many data. And then the whole data, like from the lowest to the highest point, the whole range, we call it distribution, the whole overview of it. Yeah. So what is the frequency distribution? It means the idea about the overview about the whole data, the frequency, how many it occurs at this point, at this point, at this point. Okay. So that's what we call frequency distribution. And when we want to create frequency distribution, it can also be presented in the form of tables or graph. We have to, there are 2 types of ways how we can generate the frequency table or distribution. We have what we call ungroup and group frequency table, ungroup frequency table and group frequency table. What does it mean? It depends on these 2 terms, group, ungroup and group. Okay, so what does it mean with ungroup frequency table first? Okay, Now, this is the raw data that we get, right, from any data collection. Raw data. Yeah, so it is not organized yet, right? So you need to organize it. You need to group it. Yeah. So we need to create a frequency table. So how, whenever you organize it and you transform it into a table, we call the table as frequency table. So how you want to organize this data? So maybe you can create something like this. Yeah. So for example, we can create a table consisting of, okay, this one is, it talks about what? This, before you analyze the data, you have to know the data is about what. Okay, this data is about number of absentees per class during semester 1. You have to spend a time to understand the data is about what, because that is going to be the subject of your data. Okay, so now it's about number of absentees per class. So this one is the subject. Okay, and then you create this column, and how you want to organize your data. There are two ways. The traditional, or yeah, I can say this is traditional way. Tally marks. You know this method. Like if let's say, yeah, let's say you the frequency is 1. You put it 1, 2, 3, 4, and then when it comes to 5, you strike it, and it means that the whole thing here means 5. Okay, that's why here we have this one. Okay, so this one. So that's what, yeah, you have to know that this is one of the ways. It's called tally marks. In a more systematic way, we have frequency. This is, we create another column and then we name it as frequency, or F. Yeah. So this one, you mention the numbers, the frequency, the number 2, 4, and so on. So this kind of table, we call it ungrouped frequency table. The reason why it is ungrouped, because you just spell everything. Yeah, like from this is the data, like when you see here, it's from the lowest to the highest. The highest is 9, right? So it's from the lowest to the highest. So you just list it down, all of the items from 0 to 9, and you find what's the frequency. It's without groups. Yeah. So this is without groups. That's why it's called ungrouped. This is without groups. Okay. Right. So this is another example. Yeah, this is the raw data. And this is about what? This is about nomination for the University Senate Chair. Okay. The same thing that you create a table. This is the subject, right? And this is the frequency. And this is still ungrouped frequency table. Okay, now let's move to group frequency table. What is meant by group frequency table? You're still, your objective is still the same. You want to group, you want to organize your data, but in a group manner, in a group form. Yeah. For example, I just go directly into an example so that it's much easier. Let's say this is the data that you have. Yeah, the day, number of patients. This is actually, I can say this is just the table that you have generated, like for example, ungrouped just now. But this is still called raw data, like the ORI data, initial data. Okay, so when you want to create group frequency table, now it's called group frequency table. It means first you have to create a class or a group. A group. For example, this one. This is group, or this is also called class. Okay, group or class is the same. So, but first you have to see your data first. You have to know what is the minimum, what is the maximum point. Now, what you're analyzing is the day, right? Which is, this is the subject, and the number of patients is the frequency. This is the frequency. Is it frequency? Yes, good job. What is this? One to 10. Okay. Is it related to this one? 12-day period. It's not related. Sorry. I don't think these two things are related. Is it related? Yeah. A department manager tracks the number of people admitted to emergency for a 12-day period during a visit with the following results. Okay. Row 1 to 10. What is 1 to 10? 11 to 20. One to 10. Frequency. Frequency group. Oh, I don't think so.
Doctor, I think the class is the number of patient between each day. It's the number of patient, but it's the number of patient, not the day. The class group is the number of patient.
Okay, wait. The class is number of patients. What do you mean by that? Wait. I can't see the connection between these two types of.
Because in the class between 1 to 10, right?
Yes.
There's only number of patients. Basically, the class group is the number of patients in a day.
In a day.
Yeah, so therefore, you see in the first data 1 to 10, the frequency is 2. The frequency is 2 because there's one data that is 7 and another data that is 8. So the data that is basically it's the number of days what in a day. Basically what I'm seeing here is the class group is the number of patients in a day. So class group 1 to 10 meaning is that day would most likely have the range is 1 to 10 patients. Therefore, in here, because we can see there's two datas that is between 1 to 10, which is 7 and 8, therefore the frequency is 2.
7 and 8. Wait. You are better in explaining. Where is it? Number of patients? You mean the class?
Yeah, the class group is actually the number of patients.
Yes.
In a day. It's just that we collect the data is 12-day period. It's basically the time frame. But actually in this class group, we're actually trying to we're trying to sort it as number of patients in a day.
In a day, okay.
Yeah, so therefore the frequency should be 12. The frequency in the end should add up to 12.
Okay, wait. 12. Yeah, 2 plus 3, 2, 3, 5, 5, 4, 9. Yeah, this one, you mean like 12, right?
Yes.
I'm exhausted already. I cannot really think well. Sorry for that. What is this? Okay, 12. Yeah, you're right. Number of patients. Okay, guys. I cannot think about. I cannot really connect the things at the moment. But let me give you an example. Other examples. I'm sorry for that. Wait, hold on. Thank you for the explanation. Let me try to relate something that I can relate at the moment. A bit exhausted actually after 1 hour class. What examples? Contohnya. Okay, macam ni lah. Okay, let's say we construct something else. Sorry for the problems. Okay, let's say we have this example. Thank you. Someone, siapa tadi yang explain? Later you can have a look at the example. Maybe I relate something that I can relate at the moment.
Doctor.
Okay,
My name is Kathleen.
Kathleen. Okay, thanks, Kathleen. Let's say we have this example. We have this raw data. That one is a bit like, I don't know why I cannot think that. This is raw data that we have, okay? So when we construct just now ungroup frequency table, we just list down everything from the minimum to the maximum point. And then we mention how many frequency for each of that. But when we say a group frequency table, it means that now the first thing that we have to do, we have to construct the class. We have to construct the group. Means when we want to create the table, instead of listing one by one, we create a class. Okay, we create class, and then we also have this frequency column where we count, like within, for example, certain class, how many frequency within that. Okay, for example, here, what is the minimum point here? 2 to 101. Okay, so here, what's the minimum? Okay, let's say this data, when you want to analyze, you see, you have to check what is the minimum point. What's the minimum point here? 4? Oh, 2. Yeah, 2. And then the maximum point is 101, I guess. Just now, where is it? 101. 101. What's the maximum point? Can you see? 81. 100 lah. Yeah. Can you see any point? Any 80, 92, the highest? 98?
98.
Okay, let's say 98 lah. So now when we construct the class, we should see our range of data. And then let's say here 98 and 2. So the range is 96. That's the first thing that we have to take note. And then what else? We have to determine the width of each class. So how are we gonna determine the width of each class? Let's say K. How is K? Oh, 5. Yeah. So it mentioned here, construct a group frequency table with 5 classes. Means that it should be 1, 2, 3, 4, 5 classes at the end that we want to create. And this 5 is mentioned in the question, like that represents K value. Okay, K value. So how are we gonna find the width? The width means like the class how from what to what for each class. So there is a formula for it. The width is R divided by K. 96 divided by 5, that's 19.2. But then we make it 20 because 19 point, in this case, we don't round up based on 19 because like we see something that is more than that. So that's why we choose 20, okay? 20. So means that when we start with the lowest one, 20, when we construct the classes, okay, so you have to how to determine it, like it's this one is 1.5. Okay, let me go here. So when we have 20 and then 98, and we have to determine the lower, what we call a lower class boundary and upper class boundary. Lower class boundary is we subtract 0.5 from the lowest point. That is here is 1.5, right? When we minus 0.5 is 1.5, 98, and for the upper class boundary, we add 0.5 to the upper class boundary, that is 98.5. Okay, 98.5. So that's the upper and the lower class boundary. So what else? Then we have to the width just now is, the width is 20, right? So how are we gonna know, let's say the point after it, like for example 21, the point here is like, what is actually this point here? This one, this one, this one, this one. So the width here lah, this is actually the formula. Dia kena minus 1.5. Oh, yeah, this is the formula. Okay, so let's say we want to know what is the upper value of each class. Yeah, W x plus 0.5 minus 1.5. So it's like, for example, it's 21. So you have to solve like for each class. For example, this one is 21. This one you insert instead of, let's say 1.5, you insert 19.5. Then you got like at the end 41. I hope you got what I mean. Okay, so you have to determine this value actually, 21, 41, 61 until 101 using this formula. Okay, and this is actually the lower class boundary for each class. Okay, so that's the first step. You determine the class interval. Let's say from 2 to 21, so on. And after you construct the class or group, then you determine the frequency. The frequency is like you count like how many occurrence, yeah, from the data. Let's say for the data from 2 to 21, based on the data here. Then you have to analyze your data from 2 to 21. Let's say from 2 to 21, what is the frequency? Then you have to analyze like 1, 2, what else? The next number is 4, is also between that, right? Okay, let's say I make a new order. 2, 4, 9, 9, 4, 5. You know, within this lah, within this range, yeah? 21. I hope you understand what I mean. 16, 21, apa lagi? 13, 15, 17, 18, 13, 14, 16. Anything else that I don't cover? 21, 10. Anything else? Okay, so once you identified that, then you determine what's the frequency. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Is it correct? 18 here. 18. So the frequency is 18. So you start filling in this table actually. 18, 8, ni semua. And how you want to know whether it's correct or not? You have to sum up all of this. And let's say you check with the data here. We have 1, 2, 3, 4, 5 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it should be 50 data. So if let's say you sum up this, 18 plus 8 plus 6 plus 10 plus 8, is it correct or not? Is it 50 or not? If it is not, then something is wrong in your calculation. Okay, so that is group frequency table. I'm sorry that I don't give the example for the first one. I just give this example. First, you construct the group and then you determine the frequency. So you can see the difference between group frequency table and ungroup frequency table. Ungroup, we don't have classes. We just count one by one. Okay. Right. Any question for this? You can try by yourself, yeah, the exercise here. Now we move
Doctor, is there any answers for the exercises?
I don't have the answer, but you can yeah, you can discuss with your friends. Maybe you can, yeah, if you 2 or 3 or 4 of you calculate, you could see maybe the right answer. Or maybe you can ask me, maybe I can have a look at your workout, yeah. But yeah, you can try by yourself, okay? Yeah, okay. And then we move to relative frequency table. So we talk about group just now. Now we have a new term which is relative frequency. What does it mean? So I just go directly into the example. So now just now we talk about this one, right? We talk about the classes, this one, and also the frequency. So relative frequency distribution or tables, it is an extension of what we talked just now. So this is what we talked just now. And extension of it, we have this column. We create another column called relative frequency. And also we have percentage of the frequency. Okay, what does it mean? So now we have this. We have the frequency of each class, and we also have the total number, which is like in this case is 40. Let's say in this example is 40. And then when we want to find relative frequency, when we say relative frequency, is something to do with we compare with something else. So in this case, we compare with the total n. Okay, let's say for this class is 3. So when we say relative frequency, we find what is the 3 divided by the frequency, the total frequency, which is, it will give you the value of 0.075, like this one. So you do the same for the rest. Like for example, 1 divided by 40, you got this. 8 divided by 40, you got this. And the total value, how you want to know whether it's correct or not, the total value should be 1. The reason why is because it's actually, it represents 100%. 100%. Yeah? So this one is in terms of percentage. So this one, if you convert it into percentage, is 7.5%. So it means that 7.5% of the data lies in this class. And the same thing goes for the rest. And the total should be 100%. Okay, so that is relative frequency distribution. Okay, what else? This is another example that you can try. Yeah, just go directly into the main points. I will not go into one by one. Yeah, the same thing, relative and percentage. Now we have another thing. After relative, we have cumulative frequency tables. What is meant by cumulative frequency table? Okay, so initially we talk about these 2 columns. We have class and we have frequency. And if when we have cumulative frequency, this parameter, it means we sum up from one class to another. For example, how was it? When we have the first class, 18, right? And then when we move to the second class, the cumulative frequency is now the accumulation or the summation of the first and the second class. For example, 18 plus 8 is 26. So at this point, it is 26. Okay, but the first class, it always starts with the same frequency because it doesn't have anything to be added with, yeah, for the first class. And then it moved to like from the second to the third is 32, because now 26 plus 6 is 32, until you reach the end of the class where it should be the same with the total frequency, yeah? 50 and 50 here and 50 here. So if it's not the same, there is something wrong in your calculation. You can cross-check. So this is what we call cumulative frequency distribution. So we have this additional column, okay? And then when we talk about cumulative relative frequency. So this one is you just divide it with the total frequency. Like for example, 18 divided by 50, 26 divided by 50. It will give you this value, cumulative relative frequency in terms of decimal points. And at the end, it should be 1 because it should be 100%. Yeah? So this one, there is also a percentage. If you want to relate, if you want to convert it into percentage, it's going to be, for the first one, it's going to be 36%. Okay. So this is another exercise for you. Another exercise that you can try. Okay. So that is in terms of frequency table. Yeah. So is one of the ways that how we can present our data table. Sometimes a table is enough. You don't necessarily need a graph or chart all the time. Yeah? Sometimes if you present a table, provided that the information is sufficient, is clear about what, it is enough to present or to present your data. Okay. So another way how we can present the data is in terms of graphs. So when we say graphs, there are so many types of graphs. They are bar graph, pie chart. They are maybe just like a curve, something. Yeah, there's so many graphs. And how we want to know which graph is suitable, it depends on our data. So before that, we have to understand first what types of graphs are there. Okay, so that's why we have to understand one from one to another. So for graph, we have the easiest one that you normally see in any article or data or news, bar graph. Yeah, it's understood. It's easy to understand what this graph is all about. So this is a type of bar graph, we call it. The reason why it is called bar, because this is actually bar. This is what we call bar. Yeah? So that's why it's called bar graph. So for example, if let's say we have this table, okay, we can also present in the form of table. Like when you are presented with this table, it's understood. 11 are male, 21 are female. But sometimes we want to know in terms of the distribution, how many percentage. It cannot be really presented well by chart or graph, sorry, by table. So when we have the bar graph or when we have a chart, let's say 11 out of 32, maybe how much? We can see like, let's say bar graph like this, we can see, or maybe female, we can see here, female is higher than male. No, it's better illustration. Or maybe we can also present this data in terms of pie chart. Yeah, how many? What's this? 66. Maybe like maybe this one is 66%, 34%. You can get the idea directly. Like okay, more than 50% are female. Yeah. So that's why we move to using graph or charts rather than table. Okay. And then okay, this is another type of bar graph. Okay, it can be just now is vertical. This one is horizontal. Okay, it's just different types of it, and sometimes it may be coupled with certain more than one subject. For example, this one, you have this, we call it legend. You have to know this term. This is what we call legend, because it will describe what is the dotted one, what is the stripes one, okay, when we have more than one subject. And this one, what we call axis, y-axis, right? I know you know already, x-axis. So when we talk about graph, we talk about axis that represent the subject. Okay, this is pie chart. Is very useful in presenting the percentage, yeah, because we want to know like how many percentage, is it 1/3, is it half of the class, or maybe half of the population. Yeah, it's very, very useful in presenting percentage normally. And there are many types of many formats of pie chart. Sometimes we have, this is 2D, two-dimensional. You can see like 2D. This one is 3D. three-dimensional pie chart. It's just about something that you want to make it more attractive. Maybe people use 3D or exploded pie chart. It's just different formats of it. And then we have histogram. We have relative frequency histogram, frequency polygon or GIF. I'm sure you have come across histogram, right? You have studied before. I still remember I studied that during my SPM. If I could remember, then of course you should remember more than me. You just have your SPM a few years back. Okay, so this is histogram. So histogram is a bar chart where you plot frequency versus midpoint. Let's say you have this data just now, like this is the raw data that you have. We have talked about organization of the raw data, right? This is raw data. And then when you transform it into a table, you organize it, you have the class, you have the frequency. And apart from that, if you want to construct histogram, you have to find what's the midpoint and what's the relative frequency, because you're going to plot, for histogram, midpoint and frequency, because relative frequency is for OGIF. You have to get the midpoint. What is meant by the midpoint here is the midpoint of the class. For example, between 15 to 19, the midpoint is 17. 20 to 24 is 22, and so on. Okay, so these values that you have to get. And how you construct the histogram, you construct the midpoint, the frequency versus midpoint. Okay, so frequency versus midpoint. So here you can see 17, 22, 27. So these are all the midpoints of all the classes just now. And this is the frequency. Frequency means like for the first class here, 17, the frequency is 2. And the next one is 10. So if you see the graph here, this is 2. This is 10. Yeah. So based on that information, that's how you construct this graph, which is called histogram. Okay. And then we have another one. We call it frequency polygon. It's not that really much different from histogram. It's just that from the histogram here, you take the middle point of it and then you just connect it like this one. Okay, if let's say I have this middle point, I just need, and then you connect it, and it will create what we call frequency polygon. Okay, from here. So this is what you got. Frequency polygon is actually derived from the histogram. And then we have OGIF. This is like different types of data, different types of charts or graphs that you can use. We have OGIF. So OGIF, if we see the OGIF, so this is OGIF. OGIF, you studied this at Maths 10, betul tak? In your
Yes.
SPM.
Yes.
I still remember, see? That's correct. So OGIF is relative frequency versus upper class boundary. So it's about different things that you plot, you put on the axis actually. Okay, relative frequency, how you got the relative frequency is from this one, right? Like this one. From the frequency, you divide with the total number, the total frequency, berapa kat sini? 100. So the relative is for this one, 2 divided by 100 is 0.02, and so on. So these values is the one that you plot on the OGIF. OGIF, this one, the Y, and the upper class boundary. Okay, just now for the for every class. Okay, for every class, you have to create like one column and find what is the upper class boundary. What is upper class boundary here is like is plus 0.5 from the class. Let's say here is 19.5, 24.5, the upper class boundary, 29.5, and so on until 64.5. So those values that you use to construct the OGIF, yeah, here. And it will look like this curve, okay? Right, that's OGIF. And then we have stem and leaf plot. So what stem and leaf plot is all about, this one is not that really common, tapi there is lah, there is. So what does it mean? Let's say you have this data, raw data given to you, and you want to present it. Okay, maybe you want to try stem and leaf plot method. So how are you going to present it? So this is the format. First, you have to have frequency. Frequency, of course, you know that how many times it occurs. And then we have this stem and leaf. So it's actually from the concept of plants, right? You have stem and then you have leaf. So stem is the main part and leaf is the sub parts. So let's say you have the data here. It starts from 42, right? 42 until 99. Okay, so it means that when we want to say that it starts with 40 something, right? So we start with 40. 4 is the stem. 4 is the stem, and then for 40, between 40 to 50, there are two values of 40s, 42 and 48, right? 42 and 48. So you put like the stem is 4, and then you put point, which means that here you have to define it, the width of the stem is 10. So that it means that it's actually 40, but you present it as 4 point something, 4.2, 4.8. But you multiply, actually the actual value should be multiplied with 10. That's why you define it here, the width. So for 42 and 48, there are two of them, right? So you put the frequency as 2. Okay, but the way you read it, it is understood that this thing is read by Nila 42 and 48. Okay, like for 50, there are only one 50 values, which is 56. So you can just put 5.6, only one, 56 as only one. Yeah? And the same thing goes for the rest until we got the highest one, which is 99, 10. So for 90s, there are 92, 97, 99. So there are 3 frequencies. So this is stem and leaf plot. So what is important, you have to know there is a column for frequency, column for stem and leaf, and also you have to define the stem width. Yeah. Okay. So that is stem and leaf plot. You can go through the examples by yourself. Just explain the main principles of it. The next part is percentiles and quartiles. Okay, what is that? Okay, this one basically, let's say you have the data, the original data, we call it distribution, and we divide it into quartile. Quartile means 1 quarter, like 25%. Out of 100%, we divide it into 4. So we have 4 times 25 equal to 100. So each of that we call quartile. So this one, Q2, Q1, Q2, Q3 until Q4. So this is quartile. 1 quarter. Quarter means 1/4. So means that the whole distribution, we divide it into quartile. Let's say how many data lies within the first quartile, and then the second quartile, the third quartile, and until the end. Okay, so what are important things here? You have to know IQR, interquartile range, which is defined as Q3 minus Q4. We go through an example first. Let's see, ada tak example? Tak ada. Okay, so basically macam itulah dia it tells about the spread of the data. Let's say let's say you have whatever the data that you have, the raw data, let's say from the height, let's say the height. You have 9, apa? I dah penat dah ni sebenarnya. Let's say apa ya? Apa tadi data that we have? Whatever the data lah, I give you an easy one. Let's say height lah, height. I cannot think about other example. 170 cm. Okay, 100 52, that is the range. Let's say you have adalah data ni dalam, let's say 20 points, yeah, 20 points. So if you look into that range, you have to see the lowest and the maximum point first, and then only then you can divide it into quartile tadi lah. Let's say for example, you divide it into 4. 170 divided by 20. Okay, let's say 155 here. Is it correct? Oh. The tengah-tengah is 160 and then 165. So this one, let's say this is Q1, Q2, Q3. So means that, let's say between 150 to 155 cm, there are few data that you have. Let's say the frequency is about 7 people have the height within 150 to 155 cm. So this is meant by quartile 1, means that you divide the distribution of the whole data into quartiles. 7 people are here, and then maybe here there are 8 people within the range of 155 to 160, and then 9, maybe here are 2. So you divide it into quartiles. They call it quartiles. Okay. I think that's it. It's not that really difficult, I can say. It's like yeah, into quartile. And then the last one, box plot. What is box plot? It's something related to the quartile as well, but it's just that you present the data in this kind of presentation. Okay, let's say just now you know already about the quartile 1, quartile 2, quartile 3, and you have the values. This is another example. It's not related to my example just now. So it's about, box plot is about presentation of the data, but you have this this one. Okay, this is actually represent the lowest value, and this one represent the highest value. So you make it like a horizontal line like that. And then what it has in the middle, it has this box actually. This box, and this box, the lower part represents Q1, the upper part represents Q3. This one, what I mean by the lower part, this one actually, this one, this level, this value. When you plot it, you have the axis, you have the value that you plot based on. Yeah, this is the Q1 value. This is Q3, and in the middle, in the box here, you have to construct a box like this, and this is the median. Median is the Q2. Yeah, Q2. So the percentile just now, it has some relation with this box plot. So you have to know the information of the quartile in order to construct the box plot. Okay, that's it, I think. Okay, any question? I'm sorry if I go a bit fast because I expect you to know some of the things since those things have been covered in your foundation in your school before. Okay, so basically what we have covered in the second part of LU1, we talk about summation. Yeah, summation, the symbol here. So you should know what this means and how to use it and how it is used in different contexts. You have to take note on the use of brackets, on the subjects involved. And then we talk about the second part, we talk about the different ways how to present data, different ways or different methods to present data. Okay, we have frequency distribution, that is table, group and ungroup, right? Group and ungroup. And then we have histogram, ogive, stem and leaf, percentiles and quartiles, and box plot. Okay, for each of that you have to know, like histogram, you have to plot what versus what, ogive what versus what, so that kind of things. Okay, any question? So that's all for today. It's quite a long lecture, nearly more than 2 hours. Yeah. Anything you want to ask? You're not clear?
No.
You can also email me anytime, yeah. I would answer by email if you don't want to ask here. Okay, so thank you very much for your attention. I'll see you guys in next week. Okay, please take note on the announcement. I will update the ELIP. I haven't updated it yet with the lecture notes. I will upload the lecture notes there. Okay.
Thank you, doctor.
Thank you,
Alright.
doctor.
Welcome.
Thank you,
Thank you,
doctor.
doctor. Bye-bye.
Bye. Have a nice
Thank you,
day.
doctor.
Thank you, doctor. Bye-bye.
Bye. Only 2 of you needs manual attendance. Nur Ashikin and Kathleen.
Saya pun, madam.
Yes.
Saya terap.
Yeah. Wait. Hold on.
Okay.
What's your metric number? Siapa tu? Siapa yang saya tadi tu?
Saya Zulfaka.
Sekejap, your metric number.
78.
Zulfaka. Okay. I got it.
Oh, ada.
Okay. Okay, Kathleen. Viviana, is Viviana around? Ada?
Hello, doctor. Can I have the attendance?
Viviana. Are you Viviana?
Yeah.
Okay.
Yeah.
Okay. Done for you. Okay, bye.
Okay,
See
thank
you.
you. Thank you.
Thank you, madam.
All right, welcome.